we are looking at lesson 4.4 today, which is factoring. Factoring quadratic expressions. This goes back to Algebra 1, folks. You first learned how to factor in Algebra 1. Now, how much you remember, how good you were at factoring is a whole other story, okay? My job is to review the factoring and to really work at it and make sure we know how we're going to factor, okay? This factoring will be incredibly important in solving equations in the second half of this chapter. So, and that solving equations by factoring, it carries through in Algebra 2, pre-calc, calc. It's, you know, a basic fact we have to know how to do. So, we will definitely be doing some reviewing and stuff. Jacob?
Is this the thing where we're going to have to do like FOIL and stuff?
Not so much FOIL as maybe reverse FOIL. You're undoing FOIL, so to speak.
Right.
Okay? Okay, so we're going to look at several different types of factoring. Right here, we're going to start with factoring expressions that are in the form x squared plus bx plus c. So, we've worked a lot the last couple of days, week, with ax squared plus bx plus c, right? But notice there's no a value here. So we are just doing this when it is a 1x squared. And so example A, how do we factor x squared plus 9x plus 20? Anyone out there physically present or virtually present? Remember how to factor something like x squared plus 9x plus 20. Connor?
Do you square it? Or take the square from?
No.
Isn't it like, would it be like x, like, would it be like parentheses x4 and then another parentheses x5? Would that be something like that?
Okay, if you're headed in the right direction, he's talking parentheses. I heard someone in virtual turn their microphone on, but parentheses. He's talking about x4, x5. That's in the right ballpark. You're not 100% there, but yes, that's exactly the direction we need to go. You remember, Gracie? Looking for two numbers that can add to be 9 and multiply to be 20? Is this ringing some bells out there?
Yes.
I hope it gives us a chance. Okay, so when we look at this, so first of all, Ethan mentioned two parentheses. And that's what our answer is going to look like. We are factoring into two parentheses, and I'm going to call them binomials. Okay? Binomials, because they're each going to have two terms. X squared. What times what is x squared? X times x, yes? And so the front of each of those parentheses, or the first thing in each parenthesis, is going to be x times x, because x squared breaks up into x times x. Now, to get those numbers, we have to look for two numbers that give us a product of 20. And why 20? Because 20 is my C value. Okay, so whatever that constant is, we want two numbers that give me a product to be that constant. And then they have to give me a sum of the B value, which my B value here is 9. So you want a product of the plain number at the end. So two numbers that multiply to be 20. And then they have to add to be the number in front of x. So they have to add to be 9. Now, I'm going to go old school here. I won't always do this, but a lot of you probably come up with those numbers. We've mentioned them. But here's what I always start with if you don't know what those numbers are. Let's make a list of what things multiply to be 20. I'm going back to baby steps here, okay? So if I start with what multiplies to be 20, 1 times what? 1 times 20. Okay? 2 times what? 2 times 10 is 20. 3 times what? Okay, 3 times nothing. 3 does not divide into 20. 4 times what? 5. And then the next number I'm going to try is 5, but notice we just used 5, didn't we? So those are my options. 1 and 20, 2 and 10, 4 and 5. 4 times 5 is 20, and 4 plus 5 is 9. These two numbers multiply to be positive 20 and add to be positive 9. What kind of signs do we need to use here? Yeah, two positives. Now, and I have no idea how Mr. Voth taught, if you had Mr. Voth when it came to factoring time. But I do think I teach my signs slightly different than Mrs. Rogers. I have mostly sophomore sitting here, so you guys probably didn't have Rogers. For Algebra 1, that is. But this would be x plus 4 and x plus 5.
Is the big X supposed to be like a multiplication sign? Or no, that's parentheses. Okay. They look like an X.
Is that my two parentheses next to each other?
Yes.
Okay.
It kind of does look like a weird X.
Okay. I was like, what big X are we talking about? But
Parentheses, and I didn't see it.
okay, you're seeing it now. Got it. Okay. Okay, so x plus 4 times x plus 5. Okay, what if I wrote x plus 4, x plus 5? What if you wrote x plus 5 times x plus 4? That's fine, yes? It doesn't matter which order you give me the parentheses as long as you have matching parentheses. Remind me, how can I check this answer? Not saying I'm going to check every one, but Allie?
You can combine them by doing the parentheses. It's like x times the x and then like distributing.
Okay, so she's talking about combining the parentheses, distributing, we're multiplying them together, right? So the idea here that you start off with x times x, which is x squared, and then it's x times 5, which is 5x, and then after you multiply that x by both pieces in the other parenthesis, you also do the same with 4. 4 times x is 4x. 4 times 5 is 20. And I wrote that real small, probably not a good idea since I have so many virtuals out there. But x squared plus 5x plus 4x plus 20. Does that give me my original problem? Yeah, 5x plus 4x is 9x, so that matches with the original problem. Now, I went into a lot of detail here. Am I saying you have to list the numbers that give you multiply to be all the numbers that multiply to be 20? No, but if you get stuck, that's your method. Am I saying you have to check this and multiply it back together? No, but it's an option. Okay, all I'd really have to have here is x plus 4 and x plus 5. I'm not saying you even have to show work on a problem like this. Questions from anyone? That applies to physically present or virtually present. Okay, does that sound a little more familiar now? Maybe. Was this a Voth or a Brott thing when you learned it sophomores? Voth, okay. And I have no idea how he would have taught it, so.
Yeah, he told us foil.
Okay, and which, by the way, I did forget, when Allie was talking about putting these to check them, we could multiply them together. What did I just do? We just foiled, yes? Okay, so foil is your check there. If you want to talk. Okay.
That's foil, then yes.
Just basically
Yeah,
double this.
because foil is first x times x, outside x times 5, insides 4 times x, and last 4 times 5.
Then yes, foil.
I meant to throw the word in after I finished explaining what you were talking about, and then I forgot to throw the word in. So, okay.
I think it's a lot easier than how these points.
Okay.
Just because it was a new concept to us.
Yeah, and that's,
It's
yeah.
also easy to listen.
You've had 2 years to soak it in. And even though you had Mrs. Rogers for geometry, I'm guessing you saw, well, I don't know, because you guys wouldn't have been preparing for ISTEP. I was guessing you guys maybe saw some of this along the way, but maybe not. Okay, example B, x squared plus 14x plus 40. Trying to factor it. Notice it's in the x squared plus bx plus c form.
So, all quadratics make parabolas.
Yes.
Okay.
All quadratics make parabolas, but not all quadratics are factorable. Okay. What do you know automatically about these two parentheses? Well, even before that, what goes in the front of each parenthesis? X, because x squared breaks into x times x. Now, I generally tend to do signs later, but I get it, and I think that's just how my brain works. If it multiplies to be positive and adds to be positive, both of these signs are going to have to be positives. Okay, good. What about numbers? Okay. We need numbers that are going to do what for us? Okay. So add to 14, multiply to be 40, which I usually say a product of 40 and a sum of 14. If you would rather use M and A for multiply and add, that's equivalent. Now, some of you may have your numbers already, yes? If you don't, here's my recommendation. Okay, this is always my go-to. Look at your products and make a list. And even better yet, if you're stuck, go in order. Okay, and I get it. For the easy problems, this seems ridiculous. But for a harder problem, you'll appreciate it. 1 times what? 1 times 40 is 40. 2 times what is 40? 2 times 20. 3 times what is 40? Nothing. 4 times what is 40? 4 times 10. Whoops. 5 times what is 40? 8. 5 times 8. 6 times what is 40? Nothing. You guys are all quick. You're like, you already passed the right pair. 7 times what? Nothing. And then what am I back at? 8 that I've already used. Okay? That's just how I go about getting my possible pairs.
Basically, if you get to a number that you've already used in the past, then you know that's the right.
You've gone as far as you can. And notice when I count up, I'm counting up 1, 2. Did I skip over any numbers? No, I kept all my, I checked all my numbers. So the pair that multiplies to be 40 and adds to be 14, 4 and 10, yes? So what's my answer going to be? Okay. X plus 4 times x plus 10.
That's the answer. The thing we did on the last one is checking it.
Right. This is the answer. This is as far as you have to go. If you want to multiply it back together, you can, just as a check. But the answer is our factored 2 parentheses right here. And folks, I'm going to tell you, being able to factor in lesson 4.4 is hugely important to be able to do lesson 4.5, which is solving using factoring, if I recall. Yeah. Okay. Let's try C. X squared plus 14x minus 72. What do we got to think about here, Carter?
We can start it out, I guess.
Okay. And I'm going to, regardless of whether you guys want to or not.
1 negative 72.
Okay, so wait, the idea is what? I need 2 numbers that, okay. So 2 numbers that multiply to be negative 72 and add to be 14, right? Now, in terms of multiplying to be a negative 72, what do you know about 2 numbers that multiply to be a negative?
1 plus 3.
Yeah, we're going to have to think, we're going to have some combination of plus minus. Okay? Now, I'll be honest. When I make my list of pairs of numbers, I don't worry about signs right here. And maybe some of you do. But I just go through, okay, what numbers multiply to be 72? And then when we start talking about then which ones add to be 14, keep in mind, when you put a negative on one of them, it means they're going to have to subtract to be 14. Okay? So if we start at the beginning, what multiplies to be 72? 1 and 72. Well, kind of doubt that is it.
2,
Okay,
36.
2 times 36.
4, 18.
Oh, what happened to 3? Does 3 go into 72? If you don't know, what do?
Pull up that calculator.
You grab the calculator, and what's 72 divided by 3? 24. So guess what? Oh, it does work. Okay. What about 4? Does 4 go into 72?
Yeah.
4 and 18. Does 5 go into 72? No. Does 6 go into 72? 6 times 12. Does 7 go into 72? No. Does 8 go into 72?
Yeah.
Yeah, 8's one you should know. 8 times 9. Okay, and then I just did 8 times 9, which means
9 and 8.
I'm good. Okay, because we've already got 9. Okay, do you see any of those that I say add to be 14, but keep in mind, we're going to have to do a negative and a positive here.
Yes.
So which one said is going to, quote, add to be 14?
4, 18.
Okay. If we put the right signs, 4 and 18, yes? They multiply to be negative. We said we need a positive and a negative. What about, how do we make it so they add to be a positive?
Put an 18 plus negative 4.
Okay, so if they add to be a positive, larger number has to be positive, smaller number is negative. So it's going to be negative 4 and positive 18. And you can think, negative 4 plus 18, that's 14. Okay. What's my answer?
Oh, x minus 4 in parentheses, and then x plus 18.
Okay. X minus 4 times x plus 18. Okay. So x squared, remember, breaks up with this type of factoring to x times x. We said we need a minus 4 and a plus 18, so those each got their parentheses. If you don't feel confident, you can check yourself, right? Are we okay with this?
Yeah.
It's not too bad, especially since you did it back in Algebra 1. And I don't care what your level of understanding was in Algebra 1. The valid point was made that the second time around it always goes better, right? Whether you understood it the first time or not, your brain has had 2 years of growth on it. So, okay, let's try D. X squared minus 11x plus 30. You can go ahead and set up parentheses if you want. What do you know about your parentheses right off the bat?
X and both.
X and X. Okay. What kind of numbers are we going to need to think about? A product of 30 and a sum of negative 11. Now, as we think about this one, it multiplies to be a positive. What are your options for multiplying to be a positive?
Double negative or just both positives.
Okay, so either both positives or both negatives. Since it adds to be a negative, what's going to have to be true here? Double negative. Okay. So this comes back to grasping your understanding of signs. Okay, let's see. Product of 30. This should be easier than 72. You guys know these better. 1 and 30. 2 times
15.
15. 3 times
10.
10. 4 times
Nothing.
nothing. 5 times
6.
6.
6 times
6 times, 5. We just did that one. Okay. Which pair multiplies to be 30 and provided the correct signs could add to be negative 11?
5 and 6.
5 and 6? We already decided they're both going to have to be negatives. So what's my answer here?
X minus 5. X minus 6.
Okay. X minus 5, then X minus 6.
How do we, if this is a really dumb question, I already know that. How do we get part of them both of them negative?
Okay. So we knew they both had to be negative. So when they multiply to be a positive, our signs have to be the same. So both positive or both negative. The sum is a negative. So 2 positives could never add to be a negative. So thus they have to be both negatives. Okay? Whenever, and I don't know how Mrs. Rogers teaches this, but some teachers will say, okay, whenever this last sign here is positive, that means they're both the same. And then this sign will tell you that they're both negative. That's how some teachers will teach it. There's lots of ways I could teach this. So, okay. Got the basics. Okay, so keep that in mind. We're still going to be factoring those quadratic expressions. We're not done there. But we're going to move down into example 2, where we get to talk about GCFs. And really, I probably should have been asking you on all the problems we just did if there were any GCFs, but I didn't. And what do I mean when I say GCF? Greatest common factor. So anytime you start factoring, you should always ask yourself, is there any type of GCF? Yes, Eli?
That's where you get to the point and then you find it like it's again. It's like you're going with the 5 negative earlier, where we found the maximum and then it only repeated itself.
8 and 5, and then 5 and 8.
Yeah, like on example B, an example 1 where we did the list and it went 5 and 8 and 8 and 5. Or it's completely off base here.
I'm not understanding. I'm not sure.
Okay.
I'm not understanding what you're saying in relation to GCF. So you might be on something different. I don't know. Give it a moment. We'll see. Okay.
How big I know.
Okay. So as we look at 6n squared plus 9n, first question to ask yourself, is there a GCF?
3.
3? So 3 divides into 6n squared, and 3 divides into 9n. Is 3 the only GCF?
1.
1. But we don't count 1, right? Because isn't 1 a...
1 is the default answer if we have nothing else. So 3 is our number GCF, our numeric GCF.
Are you gonna call like the negative 3?
No?
In?
Do both terms have an n in common, a variable in common?
I'm a genius.
Oh yeah, I'm very serious. Okay, GCFs are numbers and variables. It's not just numbers, which is, I think, the look I'm getting from Abby of, wait, what? It's not just numbers? Okay, which, and I'm looking at, okay, if she's saying that, how many other people are saying that in their heads? So,
It's really annoying.
okay, so what we're looking at here is that 6 and 9 can both divide by 3. N squared and n both have one n in common, right? An n to the first. So what we're going to factor out is 3n. When I factor out the 3n, then we're going to put the 3n out front, and we have to be able to write down what remains in the parentheses. So, when you're factoring it out, what I like to think is that we're dividing both terms by 3n. And this is our GCF because it is the largest term that can divide into both of them. So, okay, now we got to review. 6n squared divided by 3n. Well, 6 divided by 3 is 2. N squared divided by n. N. So my first term there is 2n. And recall, you can just subtract the exponents on the variables there. Okay. I've got a plus sign, so I'm going to carry along my plus sign. 9n divided by 3n. Well, 9 divided by 3 is 3. What about n divided by n?
0.
I don't like 0.
Well, like, it's not like, it cancels out, doesn't it?
It cancels out, but that means it cancels to be a 1, not a 0. Okay, so the idea of 9n divided by 3n is just going to be 3, because the n's do cancel. I mean, you can cancel them and they think of them being 1, and so we have 3 times 1, but that's the same thing as 3. Okay, we got our GCF. The question you always want to follow up on, is there any other types of factoring that could be done? Now, in this case, 2n plus 3 is just a basic binomial. It's not like I could factor like we did up above or anything. So we are done right there. Okay? Questions there? Okay? Look at example B. Ooh, we're going to quickly look at example B. Okay, GCF. They both have a 7. What about N? Do they both have an N?
No.
It's just a number.
Okay, the second one's just a number, so the biggest GCF is 7.
It's crazy.
So, now, if you need the visual, what are we doing to both terms? Dividing by 7. 7n squared divided by 7 leaves me with
N squared.
n squared in the parentheses minus 21 divided by 7 is 3. Notice, what did I put out front of my parentheses?
7.
That's 7. When you factor that GCF out front, you have to put it in. You have to put it out front there. N squared minus 3 does not factor any farther. Now, 3 was a perfect square, it would, and we'd have to talk about that.
What? That's not even cool.
Okay, so it's 11:01 by my clock. It's a good stopping point.
Good.
Tomorrow, we will pick up in these factoring notes. So we will continue GCF factoring, and we've got quite a decent amount of factoring to do on the back side. Okay, Math Excel is out there. You can start it. I'll be honest, I haven't reviewed a whole lot of the factoring yet, so I'm not sure how much of it you're ready for, depending on what you remember from Algebra 1, right? So, but we will pick up tomorrow in the factoring. Homework will not be due until Thursday. Is that the correct answer?